Before we welcome him onto the stage, if you haven't already, could you please download the AWS Summit app via the QR codes on the screen. Please join me in welcoming onto the stage Seb, our Senior Solutions Architect here at AWS.
Thank you.
No worries.
Good. I hope everyone can hear me, and hope everyone is having a good day at Summit today. I'm going to run this session a little bit differently, as in this session, I'll talk about myself and what my day has been like as a serverless developer. This actually really is day in the life of Seb, so hear me out. This was about 2 weeks ago. I wake up in the morning and I get an email from Steve. Steve is my boss. He's actually sitting right over there. And as Steve typically does, he sends me an architecture diagram with these two services, and he asks me to integrate them together. And I look at that email and I just take a moment and I'm like, whoa, Steve. I just need a cup of coffee here first. There's so many questions, so many assumptions I need to make about what he just sent me. How is this integration meant to look like? Is it synchronous? Is it an asynchronous? Is it point-to-point? Is one service meant to poll another? What about the data flow and the data format that I require to put together here? How am I meant to handle errors and failures and retries and some sort of backups? Clearly, Steve is missing the vocabulary when describing the intent. But nevertheless, Steve is my boss, and I have a job to do. And it was Friday that day, and I want to get this job done quick, so I'm going to use serverless to do it. And I define serverless as a practice of building solutions with deep appreciation for AWS services, which are becoming an extension of my architecture. I will be using AWS services to describe the behavior of my application and the integration patterns that exist within my application. My skill set as a serverless developer is multifaceted. I have a deep understanding of many AWS services, especially the ones that are relevant to me. I've got my favorite frameworks and tools that I use daily. And I also spend a lot of time focusing on architecture, integration, DevOps, automation, and observability. But for today, I'll just focus on these three areas. And I'll quickly touch on the tools and frameworks. I use a framework. I've got a favorite one that I like, and we all do. But all these frameworks, they have a different level of abstraction. They have different features, capabilities, dependencies, and complexities. There are many of them, but really when that boils down to it, at the end of the day, they all invoke AWS APIs, just in different ways. You still need to know how the underlying AWS services work in order to use those frameworks effectively. So for today, I'll be using the AWS Serverless Application Model, or AWS SAM. But whichever framework you select, what I really want to focus on is the composition within that framework and how my logical architecture aligns with the physical implementation together. And I want to be thinking about things like the dependencies, the granularity, and different ways of wiring elements together, maybe using managed services integrations like it's possible with SAM, and so forth. But enough about that. I've got task for today. Today, or actually Friday 2 weeks ago, I was working for Unicorn Properties. Unicorn Properties is a real estate company that manages properties and contracts for these properties. It's a serverless, event-driven application, and it consists of few microservices and some orchestration in between them. And this is what the whole architecture looks like. It's large. It's got a web function for managing properties, so then our customers can view them and our agents can manage them. It's got the publishing flow to get the properties published if they meet all the criteria and sanity checks that we want to ensure are in place. But for today, Steve asked me to work on the contract service, which is responsible for creating contracts for these properties. I spend a little bit of time getting to remind myself what the contract service is. It is a RESTful API service with the API exposed at the forefront of it. And through that API, an agent can submit a request to either create a new contract or update an existing contract. And I remember there are some business rules that we've created in this solution that the business requires us to have. There can only be one active contract for each property. And it can it's initially created in a draft state and later approved, later updated to an approved state when we're ready to publish that property on our website. We've got Lambda here that processes the synchronous requests from our agents. And that Lambda performs two operations. It saves any contract changes to the DynamoDB, that's our state store, and emits events to EventBridge. I'll quickly walk you through what this solution looks like, what this microservice looks like. So what you can see is a SAM template. We've seen a lot of those. It's got a lot of text. It actually takes me a bit of time to get a good understanding of what's in this code. So instead of that, I'm going to use the AWS Infrastructure Composer to get a better view of what this microservice looks like and how it aligns with that logical architecture that I know of. So you probably will have seen the EventBridge is not shown there, as is an external dependency in this solution. And I'm going through the code just to see, just to remind myself how it works. So in this application, to create a contract, I make a call to DynamoDB to check if a contract already exists. And if it doesn't, or if it does, I just check what state it's in order to understand whether I want to proceed with creating a new contract. So this is creating a new contract example. Just run a quick curl request to check if it works. And sure thing is, this app is working. When an API call is made, the state is saved to DynamoDB. I just tested that part. That's good enough for me. Cool. OK, so that's working. So I can start working on this service. So Steve thinks there is something wrong with this architecture and the way we've put it together so far. And I sit down and think about it for a moment. I actually initially think it looks all right. It does the job. But I give it a few minutes, kind of second cup of coffee moment, spend some time looking through this architecture, and I start asking myself a few questions. The first one is, should this be a synchronous transaction? Does the agent need to wait for the backend process to complete? And does it need to if there are any errors with the backend process processing this transaction, do they really need to bubble up to the agent? What is the agent going to do with that information? Probably just going to ignore it and try again. And the big one that I'm starting to think about is the fact that in the current implementation, I've introduced a distributed transaction here. What if I have a problem in my code that will result with my application saving an entry to DynamoDB, but not sending an event to EventBridge? My consistency is at risk here, and I'm potentially going to have major operational overheads later down the line. And last one that's been frustrating me personally is the external dependency that I have on the event bus. And what it means when I want to work on the services, I cannot deploy this microservice on my own. I need to ask the platform team to provision those external dependencies. And I've also got those dependencies hard-coded in my Lambda code. So I'm not a fan of that either. And I sent this back to Steve, thinking, like, how about we make a few changes here to resolve some of the things I thought about how we can improve this application. And I want to go ahead with the asynchronous approach. I'm going to introduce an SQSQ to queue any requests coming from agents to create or update the contracts. And when the request is queued, the agent is going to receive 200 response that your request has been accepted, and we will process it sometime soon. I'm also going to change my Lambda function to only perform one operation. It's only going to perform one step change, which is saving a contract change to DynamoDB table, and then I will stream the changes from DynamoDB using Amazon EventBridge pipes to the EventBridge that I own in my own account. So this looks good to me. And I break this down into 3 transactions, and I'm going to go ahead and implement them today. Starting with AWS. One thing you will notice is I don't have another Lambda on this picture between my API gateway and SQS. I don't want to manage more codes. I don't want to manage more Lambda functions. So I'm going to try and implement this natively. Let's give it a crack. So I'm going to, instead of doing this in code, I'm actually going to give the infrastructure composer a try. It looks good, gives me a nice intuitive feel for how I can drag and drop some services here. So I drop an SQS queue, I give it a name. I'm going to drop a dead letter queue as well, so we can capture any requests that we couldn't process. And I'm actually just going to have one SQS queue. I'm going to send both post and put requests, so to create or update the contracts to the single queue. And one other thing I'm thinking of doing is instead of having those API integrations defined in my SAM template, I'm going to use an external OpenAPI file to do just that, because I'm more familiar with the OpenAPI spec. So that's what I'm enabling just now. Infrastructure Composer supports it nicely. Tick a box to use an external API file, and you will see, we will just review the changes in my template. Let's have a look. So that's my Lambda function. You can see the event that's been taken out, so it's no longer triggered by the API. We'll deal with that later. And we've got our API here, and you can see the definition body. It's pulling this API.yaml file, which is an OpenAPI spec file that I'm more familiar with, and gives me that explicit, more familiar, that's why I explicitly define the integration between the API and SQS. I'm making a change to a request mapping template that I will get to in a moment. I'll explain that on the next slide, as it's just a bit easier. But I'm really copy-pasting the same implementation for my put request as well, and I'll be sending both of them to the same queue. And to get a visual view of what I've implemented, yep, that looks about right. So leaving the Lambda functions aside, and my SQS is hooked up to my API, I'm just going to quickly deploy this change, and I'm going to see if it works. OK, I sent some curl requests to the API, and there are messages in my SQS queue now. So that was simple. That actually worked nicely. There's a little bit of magic I've introduced here with that native integration between the API gateway and SQS. And I've used something called integration request mapping template in order to invoke the SQS send message API directly from my API gateway. And I've mapped the SQS message body as the payload of the HTTP request. And I'm using message attributes in order to pull the context of the request and the HTTP method that was used in this request, and I'm passing it as message attribute in the queue, in the message, so I can do something with this later, so I can process it later. So when I know that when I read the message, I know whether it was a post or a put. Good. OK. The next thing I'm going to do is I'm going to look at the Lambda function, and I'm going to make the changes to it so it reads from the SQS queue properly. So this is actually a true story. I was hungry and I was getting for lunch. And I was initially going to use Infrastructure Composer again. But I really wanted to get this done quickly. And my colleague Michael suggested that we go and get sushi together. So I decided to try the queue developer and try the new agenting AI features that I actually didn't get to try yet. So I'm going to go ahead and do just that. I'm going to go straight to Amazon Q. I'm going to paste the prompt. And I've actually got a cool true story here. So this was actually all done in a day, first take, and I was actually going to use this infrastructure composer to put this demo together. I've done that before with Steve, but this time I thought I'll use the Q developer. I've written my prompt. I hit the record button on this video, and this is the first try of running my prompt, which effectively asks Q developer to make certain changes to, I'm actually asking it to create one Lambda function that will read messages from the SQSQ, read that message attribute that I've just created in previous step, and decide to either run the create contract method or update contract method, depending on whether it's a post or put. And let's have a look at the changes that Q has made for me. Okay, this actually looks good. So I've got my contract handler. I've got the event, so it's triggered on message from SQS. The second Lambda function is being removed, so I've only got one. And let's review the actual function code. So Q developer has created logic here where it iterates through the records in the SQSQ, pulls that message attribute, and invokes the method depending whether it's a post or a put. I was actually really impressed with the results I got here on the first try. And while this is still going, we're doing more code review, all my business logic checks out. Q's done a good job of reading my existing implementation and making the changes I wanted it to make. So I'm going to go ahead and deploy it and see if it works. I think I need to click a button for that. Yeah, that's right. Okay, good. So let's deploy those changes. I'm going to purge the queue as well in a moment, just to make sure we're on a clean slate. Good. While this is all deploying, let's have a look at the infrastructure composer. This actually all looks exactly as I intend to implement it. The architecture I've created, when I look at the physical implementation, nicely aligns. I send a curl request, and I can see an entry created in DynamoDB. So my solution is working, and it worked at the first attempt. I actually thought this is class, and I was really happy with this. I enjoyed my lunch. I actually ended up having 2-hour lunch. Michael took me to a nice sushi restaurant, loved it. And I thought, I'm going to do, for the rest of the day, I'm just going to use more Q, and I actually don't have that much more to do. But Steve's been kind enough to call me towards the end of my lunch. And Steve tells me that he forgot to mention that we can improve the way we do our DynamoDB implementation to make it more efficient. And Steve is the boss. Thanks, Steve. That's what I need on Friday at 3 p.m. But anyway, I'll look again at the current implementation of the DynamoDB. Looks okay to me initially, but can we make it more efficient? And Steve keeps talking to me about something called condition expressions, which is a feature within DynamoDB that allows me to make DynamoDB only perform the operation successfully if it meets specific conditions. So I'm going to ask you to implement just that. I'm going to ask you to only make one call to DynamoDB. So instead of reading and then writing to DynamoDB, I'm just going to write to DynamoDB. And instead of having the logic about the conditions I want to have, whether contract in which state it is, I'm going to make one call to DynamoDB to save the contract, save a new contract, create a new contract, either if the a entry for the property ID doesn't exist, or if it exists, if the contract is in one of the states that I'm okay with, so like cancelled or expired or deleted. So I'm literally asking Q to do that. Again, this is the first take. I've wrote the prompt, hit the record button, and let Q developer do its thing. And sure enough, it does. So I'm looking through the logic. Okay, so you can see the condition expression there for creation. So the attribute property ID does not exist, or exists, then the contract is in one of those states that I'm okay with, like cancel or expired. So it's not an active state. I reviewed the rest of the changes. They all actually look pretty good for me for the first attempt. So I'm going to go ahead and implement those changes, deploy them as they are. So run a quick deploy and test to see if it all still works. And as you will see in a moment, sure enough, it did, which I was very happy about. And condition expressions are great. So not only I've reduced the amount of my Lambda code, I reduced the amount of operations I'm performing against my table. So as we scale up this application, which we're planning to do, like it's just going to run better. And I think it's the way to go with condition expressions where they can be used. So as you can see, things are working. I've created a new contract. It passed through those condition expressions. I know the condition was valid, so it all worked. I obviously did more tries here, but we're precious for time, so I will keep moving through the demos. One of the other things I wanted to talk to you about is the fact that we initially decided to have a single event bus in this solution. Kind of made sense at the beginning, just a central event bus, all the services subscribe to that event bus, and we've got an event-driven architecture. But we are using events as a way of decoupling these services. And no service should have a direct connection to another. And all communication across the service boundaries should be done via events. And I've got these three services with their discrete set of responsibilities. And I believe that the publisher should own the means by which it publishes the events and should own its own event bus. This architecture approach also allows me to move to a multi-AWS account architecture where each of these services lives in its own account. And the subscribing services can manage their own rules in my event bus when they are interested in certain events. And my whole microservice, it's all self-contained. I can just deploy it on its own, and I don't need to worry about any external dependencies. And on top of that, one other thing I haven't done is I want to remove my Lambda function calling the event bus directly. I'm going to take off that code, and I'm going to use the event bridge pipes. So I'm going to go ahead and do that. I will remove the code that effectively just going to check what that code does. Exactly, just makes an API call to event bridge. Just publishes the event. So I'm going to take it out from my Lambda. Also realize my I've got some leftover files here that I'm skipping because we are actually rushing. I've got 6 minutes left here, so let's move forward. And that's what it looked like for me on a day. Just getting it all done so I can leave home early and hopefully make it for the happy hour, actually. So let's have a look. Where was I? That's right. OK, so what I'm going to do while the changes are deploying, remove the sending events, I'm just going to check the DynamoDB streams is enabled. It is enabled. What this means is I can now make API calls to DynamoDB streams to check for any changes. And Event Bridge pipes can integrate directly with DynamoDB streams in order to pull events, pull changes, from DynamoDB and send them to a target. In my example implementation, it will be an event bridge. So I'm going to implement this just now. I made an API call earlier to see what the sample event for my implementation looks like. And I'm just paste it here, and I'm just going to create a filter because I'm only interested in sending an event when a new contract has been created in a draft state or updated to an approved state. So I just create my filter. That works. OK, I think that's pretty good. Let's skip the enrichment. I'm going to pick a target. I was rushing, so I'm sticking to my central event bus just now. That's an easy change for me later when I create my own event bus. And I am, as you notice, I'm using the GUI to do this because I found trying to do this in code to be actually a little bit complicated. What I don't have time to show you is that this implementation, once created, you hit the button, you generate CloudFormation templates, and you can include that in your infrastructure as code implementation. I found it just a bit easier and quicker that way, so I prefer to do it like that. I'm using a transformer to effectively create the output of this event to look exactly like the events looked like before. Changing the way I'm sending them, but I actually want those events to look exactly the same. So whoever is subscribing to these events doesn't need to change their application, change their logic. That's what Transformer allows me to do. And it's pretty easy to pull certain properties from my source event and turn them into different objects before it hits the target. I'm creating the event bridge bus, and I'm just going to run a quick test. Just going to clear the queue, clear my table so I can send out the curl request so it all works. And let's see. Okay, that worked. And I'm just going to check. So I have a sample event, sample role that sends all events to CloudWatch. And you can see same events being created here, but the source says event bridge pipes. And if you cut it, you could see a previous event I had on this video that was from my original Lambda function with the detail looking exactly the same. So that's good. I'm happy with that. That's a good integration. That gets me where I want to be. And let's keep moving. Okay, so that's implemented the whole thing, but Steve also wants me to work on observability of my application. And he wants me to focus on the serverless best practices. I also want to implement serverless best practices, but I want to do it with a toolkit that's already available. That's where Power Tools comes in play. Power Tools allows me to implement serverless best practices consistently across a number of different runtimes and helps me do this quicker, increases my velocity. So I'm pretty happy about that. And I'm going to use some core utilities of logging, tracing, and metrics to give it that basic observability. But there are many other ways and many other features available within Power Tools. But most importantly, Steve tells me about Michael Walmsley, who is one of the AWS heroes, who might be somewhere here actually. And Michael is an absolute hero, absolute legend. He created a model context protocol that enables large language models to search through the AWS Lambda Power Tools documentation. I go on Michael's GitHub page. I have a look at the instructions to implement it. Looks pretty good, looks pretty quick. So I'm going to go ahead and implement this solution, because that means I can ask you to implement all this observability, again, without me having to do this manually. So I quite like that. I think Michael is a legend. Thank you for doing that. It's one of the community plugins available on GitHub. So I'm going to quickly go ahead and do that. Just to have a quick look at what my logging looks like at the moment. It's terrible. I've got no logging at the moment. And yes, we all know we could add some logging here manually, but Power Tools gives us a structure and implements a lot of best practices on how we should be doing logging, as well as including metrics and tracing. So again, I've created my query. I've asked QDeveloper to add tracing to this application, trace all the segments, all the methods that I've got in my code. I ask it to add some logging, and I ask it to add some metrics for every time a contract is created or updated. And as before, it was probably just getting close to 4 p.m. So I wrote my prompt, and I hit the record button to see what happens, and that's the implementation. Oh, and the other thing I asked it to do is to use a SQS data class. So for those of you that used Lambda before, especially with Python, the event is not a strongly typed object. Power Tools allows you to turn it into a strongly typed object, which again is nice for that developer experience of when you're then interacting with the event object. I implemented these changes, I ran with them, and the funny thing was, actually, I got an error the first time I tried to I ran the curl request and test. And as you can see, I've got an error here on the line 66, unsupported HTTP methods. I was a bit worried. I was worried I won't be able to tell you that it was the first try, but it was super simple fix. I don't know why. The Q developer just made a change it wasn't meant to make. I figured it out quickly enough, fix it, redeploy it. And okay, that looks better. That's working. Let's have a quick look. The metrics and logs, and this thing is flashing at me, and I promise we're finishing soon so we can both enjoy the rest of our day, and I hope you have something fun planned for the afternoons after the summit. I'm checking. The logs look good. The metric is here as well because I sent that curl request, so it created the metric. And the most coolest thing is the tracing. So just a single query, add tracing everywhere. And it created me a proper trace of my whole application across all of these microservices. And I've got all the segments here. I can understand the performance of my application really well. And it was as simple as that. I was actually really happy with that. And I think Michael is a legend. Thank you, Michael. Cool. All right. Thank you for joining. It was a good session. Some key takeaways. Serverless is cool. It's about building solutions. Use it. but use it with the tools that help you do it well. The Queue Developer, I think, is a good tool that allows you to make it quicker and better, and these MCP servers are a cool feature. There is a lot of AWS-provided MCP servers, as well as community ones, and use the power tools when you implement code in Lambda. But most importantly, what you saw today is a part of a bigger workshop. It's a full-day advanced level 400 workshop where you get to be yourself, where you get to become a developer, a serverless developer for a day for unicorn properties. A big workshop, advanced workshop, you learn a lot of the techniques that we like to preach about, and this was just a taster of those techniques. So I hope you enjoyed this session, and I will hand you back over. Thank you.
What an awesome way to end the day. Thank you, Seb, for showcasing to the audience tonight what is involved in the day-to-day processes of being a developer. This session marks the end of day one for the AWS Summit. Thank you all for sticking around with us for the whole day. In a moment, I'm going to be putting the QR codes on the screen. Please do take the time to provide Seb with feedback via the AWS Summit. See you all tomorrow.